Hello everyone, so welcome to Zelin's class, and today we're going to talk about implicit differentiation. And this is a very hard topic, and I hope you spend more time on it because I feel it is quite struggling too. And so let's start. So there are two functions which is called the explicit function and the implicit function. For the explicit function, it is just a normal function, so such as y equals x squared. So you can write the function in terms of y. So like y equals x squared, and when you do differentiate, you can straightly get 2x. However, for implicit function, your y is not the subject of the function, so which means you can't change y as your subject of the function. So like this function that you, however you, whatever you try so hard, and you still can't change the subject into y. So which means that this is called the implicit function, and we need some other skills to differentiate this. So now let's start a basic example. So y equals x cubed plus 5xy plus y. Well, actually, let's just say differentiate x cubed plus 5xy. Well, let's try to do this. Before we are doing this, we should revise our power rule and quotient rule again, which is y dash equals u dash v plus uv dash. However, in this case, so when you are dealing with implicit functions, this formula is not that important. We should convert into this formula. So such as y dash, which means the differentiation of y, and so we write into dy over dx. And for differentiation of u, we write in du over dx. So we have v times du over dx plus u times dv over dx. And similar here for y dash. So when I'm doing that, you will find that these two formulas, by using that, will be very useful. And also I need to point out another thing that is called the chain rule that we talked about 2 classes before. So which means that du over dx can change into du over dy times dy over dx, and this is our chain rule. And it is also very important when we are dealing with implicit functions. Okay, so now we are used to all of those rules, and now let's start this question, which is differentiate x cubed plus 5xy. So let's do this. Well, firstly, our aim is to find dy over dx, right? This is our aim. So which means that, so let's try this. So we have dx cubed plus 5xy over dx. Well, let's assume that this is equal to z, and which we have which will get this form, which is the differentiation of the function. And so now we can split this into 2 fractions, which we will get dx cubed over dx plus d5xy over dx. Yeah, because let's just swap these two. And so now, for dx cubed over dx, it's an explicit function, so such as that. So we can write this as 3x cubed. However, for this one, you can't do it, so we're still going to leave it here. And now, if we want to differentiate 5xy, we should expand this into 2 fractions. So how do we expand this? Let's use our product rule. So let's divide 5xy into 5x and y. So now let's apply our power rule. So we will have 5x times dy over dx plus y times d5x over dx. Well, by using this rule. And for d5x over dx, we know that this is equal to 5. So we have 3x squared plus 5y plus 5x times dy over dx. And we solved it. So this is our differentiation, which means that this function, which x cubed plus 5xy is equal to this function. Okay, so yeah, that is an introduction of the implicit function, and it is quite difficult. So now let's go into do a super hard question, which is this question. It says find the stationary point on the curve x squared minus xy plus y squared equals 48 by finding the d squared y over dx squared and determine the nature. So we have talked about nature in last lesson, and now for d squared y over dx squared, this is just mean y dash dash. So second time differentiation. So for y equals x cubed, y dash equals 3x squared, and for y dash dash you just do another differentiation, which becomes 6x. Okay, so now we understand what the question means, and now let's try this question. So x squared minus xy plus y squared equals 48. And firstly, let's find, because we need to find stationary points, so we need to find dy over dx. And now, because this is an equation, right, so we can do differentiation on both sides. So we'll have d bracket x squared minus xy plus y squared over dx equals d48 over dx. And we know that d48 over dx is equal to 0 because it's a constant. And when you're doing differentiation of a constant, it becomes 0. So now we have dx squared minus xy plus y squared over dx equals 0. And now let's try to expand this, which will become dx squared over dx minus dxy over dx plus dy squared over dx equals 0. And now so dx squared over dx will become 2x. And for this one, let's apply our product rule again, which becomes minus x times dy over dx plus y times dx over dx, and then plus dy squared over dx equals 0. And for dx over dx, it becomes 1. So we have 2x minus x times dy over dx plus, will become minus y plus dy squared over dx equals 0. And we have, so now for this part, we are going to apply our chain rule. So this will become dy squared over dy times dy over dx. And we can see that this and this is exactly the same thing if you cancel the both of the dy's. However, so if we have dy squared over dy, we can change this into 2y. So we have 2y times dy over dx. And now our answer will be 2x minus y minus x times dy over dx, and then plus 2y times dy over dx equals 0. So we have dy over dx times 2y minus x equals y minus 2x. So now we get dy over dx equals to y minus 2x over 2y minus x. And because we are going to find our stationary points, this means that the differentiation of the function is equal to 0. And now we get y equals to 2, so y minus 2x equals 0, y equals 2x. And this is only the first part of the question. And the second part, because we need to, by finding the differentiation of d squared y over dx squared, so which means we need to do this again. Okay, so now firstly because our function is x squared minus xy plus y squared equals 48, and we get y equals 2x for our stationary points. This means if we want what the stationary points are, we need to substitute back into the original equation. So we will get x squared minus x times 2x plus 2x bracket squared equals 48. And we have x squared minus 2x squared plus 4x squared equals 48. And we have 3x squared equals 48, x squared equals 16, x equals positive negative 4. And this is our two stationary point, which is 4, 8, and negative 4, negative 8. Okay, so now let's try to find difference d squared y over dx squared, and we are going to start again. So firstly, now we have dy over dx equals y minus 2x over 2y minus x. So now let's do d bracket dy over dx. So we do differentiation on both sides again over dx, which is equal to d squared y over dx squared is equal to, well, this is a fraction, right? So fraction, we are going to apply our quotient rule. So how do we do quotient rule? We have 2y minus x squared on the denominator, and for numerator, we are going to separate it. So it will become 2y minus x times dy minus 2x over dx, and so we have a bracket here, and minus, so uv dash, which is y minus 2x times d 2y minus x over dx. Well, it's quite complicated, right? It's hard to simplify it. So let's try to simplify this. Times, well, this becomes 2y minus x times dy over dx. And then minus, well, d2x over dx will become negative 2. So we have negative 2 times 2y minus x. And for this part, minus, well, we have y minus 2x times d2y over dx, which, so d2y over dx will become 2y over dy times dy over dx, which is 2 times dy over dx. So this part, we have 2 times dy over dx. And, well, let's add another bracket here, and for negative dx over dx, we have negative 1, so we times, well, so we have, so minus 1. And now, well, there are so many brackets here, so let's try to simplify this. Well, for this part, we will have y minus 2x times 2 times dy over dx and minus bracket y minus 2x. So only for this part. And so let's simplify it. This will become 2y minus 4x times dy over dx. And so we have 2y minus x minus bracket 2y minus 4x dy over dx. So we, by combining these two terms, and here is a negative sign, so we get this, and this is becoming 3x times dy over dx. And now let's combine the terms without dy over dx. So for this term, which will become negative 4y plus 2x, and for this term, well, it should be plus y minus 2x, because there are two negative signs here and they cancelled out, and this is equal to negative 3y. And so we have 3x times dy over dx minus 3y, and this is our d squared y over dx squared equals that. And now, because we know, so now we are going to substitute both of these values in, and we have, so because dy over dx, when you substitute these values, it will become 0. So all we left is negative 3y. So we only need to apply the 3y inside. So let's apply the value of y. So when y equals 8, negative 3y equals negative 24. And for negative 24, it means that this is the minimum point. It is the minimum point because here is negative, and for y dash dash is smaller than 0. This means that the function is, maximum point. Because when y dash dash is smaller than 0, this means that the function is convex. Yeah, this is concave or convex, whether it's like that. So when y dash dash is smaller than 0, so this point is maximum. And for y equals negative 8, negative 3y equals 24. And for this, it's the minimum point, because if y dash dash is greater than 0, the function is like in this shape. And if it's in this shape, then this is the minimum point. And that is our nature. So our nature will be when x is equal to 4, we have maximum point. And when x equals to negative 4, we have minimum point. Okay, so that is this question. And I hope you understand this question. And thank you. And that is all for today. And thank you. And also, if you are doing GCSE maths currently, you can find a channel by Daniel Dallas, and he is very good at explaining GCSE maths, and I like his channel a lot. Okay, thank you for watching this video, and see you tomorrow.